What's happening, dogs? Mr. Allen here with some solving of equations by factoring. And for these four examples here, we've got degrees of 4. Oh my goodness. And some lead coefficients. Holy guacamole. But you may notice these are all trinomials. They're already equal to 0. That's a plus right there, right? But we can actually factor them using the same kind of strategy we would for a quadratic trinomial. Okay, so check this out. First one. All right, what multiplies to negative 18 and adds to 3? That would be 6 and negative 3. So my factors are going to look very, very similar to what I would normally do for a quadratic trinomial. I'm going to have my positive 6 and I'll have my negative 3, okay? But instead of x and x, I'm going to have x squared and x squared. There we go. So x squared times x squared, that's x to the 4th. Negative 3 times 6, that's negative 18. 6x squared, negative 3x squared, adds to 3x squared. Boom, diggity, dope, awesome. All right, so we are factoring using essentially quadratic form, some people refer to it as, okay? Same strategies as a quadratic trinomial, just with a degree of 4. We got this. All right, so can I factor any further here? No. I'm going to set each factor equal to 0 now. X squared minus 3 equals 0, and x squared plus 6 equals 0. So if I add 3, I get x squared equals 3. Square root on both sides to solve, and I get x equals plus or minus the square root of 3. I can't simplify the square root of 3. That's it. We're done with that one right there. Next one right over here, I got to subtract 6. I get x squared equals a negative 6. Square root on both sides, just like I did, and I'm going to get x equals plus or minus. What happens with the negative in the square root? Take an eye out, right? Imaginary number, root 6. I can't break down the square root of 6, so that is what it is. And I've got 1, 2, 3, 4 solutions here. It's a degree of 4. That is the fundamental theorem of algebra right there. In action, dogs. Degree of 4, 4 solutions. They might not be 4 unique solutions, but 4 solutions no less. 2 real, 2 imaginary. Awesome. All right. Next one here. Once again, think of it in quadratic form, right? Like a trinomial, a quadratic trinomial, what multiplies to 4 adds to negative 5. That'd be negative 4, negative 1. So we can factor it the same way, except we got x squared minus 4 and x squared minus 1 as our two factors instead of x minus 4 and x minus 1. Awesome. All right. It's always great to be able to relate back to old math concepts to help you solve new math problems. All right. That's a common practice here in mathematics, even though sometimes it doesn't seem like it's similar, right? We are trying to pull from prior knowledge and apply it here to make our life a little bit easier. Can we factor these? Yes, we can factor this one. It's going to be x minus 2, x plus 2. Can I factor that one? Heck yeah. X minus 1, x plus 1. Could I have also just set those two equal to 0, solve using square roots? Absolutely. Because I put in the directions solve by factoring, I figure let's factor this thing all the way through and solve it. If we just asked you to factor the trinomial there, that's my answer. But we are solving, so we're going to set each one of these equal to 0. X minus 2 equals 0, so x equals 2. X plus 2 equals 0, so x equals negative 2. X minus 1 equals 0, so x is going to equal positive 1. And x plus 1 equals 0, so I get x equals negative 1. 4 dope solutions. You could also write it as x equals plus or minus 2, x equals plus or minus 1 if you want to save a little bit of time. All right, there we go, guys. Nice work so far. Nice work. I guess I'm complimenting myself in that video, but I bet you guys are doing great work too, okay? I can't see right now. I can feel it, okay? You guys are doing great work. Okay, let's move on. Oh boy, lead coefficient. Nobody likes factoring with a lead coefficient when it's a trinomial because it can be kind of a pain, but all right. I like to use guess and check when I'm dealing with prime numbers or very manageable numbers. So we're going to go guess and check style. If you wanted to break this apart and do factor by grouping, aka rainbow method, you're more than welcome. But I'm going to show with factor by grouping. I'm going to show with guess and check here, okay? So I know I'm going to have my two factors. I know the only way to get 2x to the 4th is 2x squared and x squared, or vice versa. How do I get 5, right? Well, that's 1 and 5 or 5 and 1 for multiplication, right? So if I were to put 5 here and 1 here, I'd get 5x squared and 2x squared. That adds to 7x squared, not 11x squared. Whoops, let me move my markers. Okay. If I flip-flop it, I put 5 here and 1 here, I'd get 10x squared, 1x squared. That adds to 11x squared. That's our winning ticket right there. Awesome. All right, so can I factor any further? Not a difference of 2 squares, not a difference of 2 squares. Not going to be able to factor this thing any further. It's time to set it equal to 0 and solve. And oh boy, it's looking like we're going to have some imaginary solutions on this one, because I'm going to have some square roots of some negatives here, man. Get ready to enter imagination land. Okay, we're going to subtract 1 and divide by 2. I'm going to do that in one step here because we're going to be taking a little bit of room for some work. So x squared equals a negative 1/2. Square root on both sides here. And I'm going to get x equals plus or minus. We're going to take I out, right? If there's a negative inside the square root, we could take I out. In the numerator, I'm going to write this with 2 different square roots. You can write it as square root of the entire 1/2. But I'm going to write it with 2 separates just to see the math a little bit easier, in my opinion. That's going to be a 2 right there. All right, that's a terrible looking 2, and I'm making it worse. Okay, so square root of 1 is just 1, right? So we got x equals plus or minus I. We've got 1 over root 2. Root 2. Can I leave it like that? Am I allowed to have a square root in my denominator? No. Some old dude a million years ago said, no square roots in the denominator, and we've decided to continue doing that. I don't know why. There's no point. But it's mathematical law for some reason. Okay, so I'm going to rationalize. Multiply by root 2 over root 2. And my final here is x equals plus or minus I. 1 times root 2 is root 2. Root 2 times root 2 is just 2. Boom. Dope. There we go. It's awesome. It's fantastic and wonderful. All right. Next one over here. Not as bad. No fraction this time. We got x squared equals negative 5. Square root on both sides. I get x equals plus or minus I root 5. That was a nice break after that one. That was a beast over in this area here. But nice work. Awesome. Fantastic. Let's do one more. One more. All right. So once again, I got a lead coefficient in this one. Terrifying, right? And it's an even number. This is not a prime number over here, right? We got 1 and 4, 4 and 1, 2 and 2. That can all make that, right? But the 3, it's 1 and 3, 3 and 1. One of those needs to be negative. One needs to be positive. I think we can still do this with guess and check. And I'm going to show you my strategy. So I got my 2 factors here, right? Equals 0. I start with the 2 closest factors. 2x and 2x are numerically closer than 1x and 4x, okay? It's not going to work every time. That's how I start these, okay? And then I start moving further apart. It seems to be that the closer ones together are the ones that frequent the factoring land more often, okay? So now I'm going to have 3 and 1, 1 and 3. Now, does it matter where I place the 1 and the 3? No, because it will multiply out the same. This is going to give me 6x, squared and squared. Woo! This is going to give me 6x squared. This is going to give me 2x squared, right? So either way we slice it there, 3 and 1, 1 and 3, it's going to multiply out the same. So now we can just focus on our negative and positive. 6x squared, 2x squared. If 1 is negative and 1 is positive, could that add to 4x squared? Yes. If my 6x squared is positive and my 2x squared is negative, we're money. There we go. So we got this thing factored. Now we can set them equal to 0 and solve. So I've got 2x squared minus 1 equals 0. So we got x squared equals positive 1/2. Square root on both sides. I'm going to get x equals plus or minus the square root of 1/2. Now, if we think back over here, remember we had 1 over root 2, and I rationalized by doing root 2 over root 2, and we get x equals plus or minus root 2 over 2. That one, the root 2 over 2 is a common one that comes up in trigonometry. Okay, so you'll be seeing 1 over root 2 and rationalizing that quite frequently in mathematics. All right, next one here. We got ourselves 2x cubed plus 3 equals 0. So I'm going to have x, why did it say cubed? Squared. All right, so 2x squared plus 3 equals 0. I'm going to subtract 3, divide by 2. I'm going to get negative 3 over 2. And then I'm going to square root on both sides. So I'm going to get x equals plus or minus. It's a negative in there, so I. And then we have root 3 over root 2. Okay, I like to separate those because then it reminds me of how I want to rationalize and things like that. I need to multiply by the square root of 2. But the square root that's in the denominator is what I'm multiplying by. So we're going to do that. Root 2 over root 2 there. Why can I multiply by root 2 over root 2? That's a good question. Well, anything divided by itself is 1. And multiplying anything by 1 is itself. So we're really not changing the answer here. It's going to look different, but it is equivalent, okay? So that's important when we talk about, multiplying by a creative form of 1, as they sometimes say. All right, so we got x equals plus or minus I, and then we got 3 times 2, that's root 6, over root 2 times root 2 is root 4, which is 2. Boom. There we go. There we go. 4 answers, 2 imaginary, 2 reals. Some dope stuff right here, guys. All right, that's awesome, man. There we go. So we got some factoring, solving by factoring. There's a ton of factoring there. If you're watching the long form here, you've made it all the way through this bad boy right now with all the factoring. It's probably going to be like 30, 40, 45 minutes. I don't even know how long. Thank you guys for tuning in here and joining in all the factoring fun. And if it was just this one that you watched right here, pop back, man. There's tons more factoring to go on the Mr. Allen Math channel. So like, subscribe, math, YouTube. Awesome.